everyone, welcome to Raos Academy. In this session we are going to discuss exogenic forces and after that we are going to discuss landforms. First, in exogenic forces, in previous sessions we have discussed endogenic forces. Exogenic forces, they operate on the surface. First, weathering, mass movements, erosion and deposition. First we will see weathering. In weathering we have three different types of weathering: physical, chemical and biological. In detail we are going to see weathering process. Weathering means breaking of a rock, crack formation, breaking, alteration of rocks and minerals. That process is known as weathering. In weathering we have three types: physical, chemical and biological. In physical weathering, disintegration of rocks into smaller fragments. First, breaking down. No movement is seen in weathering, only breaking down smaller fragments without any change in their chemical composition. Only they are breaking physically, you do not see any chemical change in those mineral composition. Key characteristics: no chemical change in minerals, this is very important, produces angular rock fragment. Here weathering, angular rock fragments you will see. Next, increases the surface area. Because of that crack expansion you will see increase in surface area. Because of that increase in surface area, what accelerates? Chemical weathering. In these cracks, if any rainwater or any chemical composition, chemical reaction happens, that is known as chemical weathering. Dominant in extreme climates, hot deserts, cold regions. Next, in physical weathering we have different types of physical weathering. First one, freeze-thaw weathering, physical weathering or frost action weathering. In frost action weathering, this frost action weathering you will see in polar regions or ice capped snow covered regions. What happens here? If this is a rock, because of the rainfall, water enters the cracks. If a rock is having cracks, because of water enters the cracks, if this is a crack, now here you will see water. When the water freezes overnight, in frost action what happens in polar regions, because of extreme climatic conditions, at night it will freeze, again during day again it will thaw, means it will melt. Because of this melting and freezing, you will see expansion and contraction. Because of that freezing and thawing you will see expansion of the crack, and after that expansion, repeated expansion and contraction causes further crack into rock breakdown. Now this frost, first frost ice, it expands, exerts pressure, again water, contraction, again frost, again water, again rainfall happens, more water, more ice, more expansion, like that continuous process it will break the rock. Temperature fluctuates around freezing point. Presence of joints and moisture is important. Next, thermal expansion and contraction, insulation weathering. Occurs due to daily temperature changes, day and night temperature changes. Because of the day and night temperature, you will see thermal expansion and contraction. Rocks expand during the day because when temperature increases, expansion happens, and contract at nights. This different minerals expand at different rate. If a rock is having 3 to 4 minerals and one mineral is expanding at different rates, what happens? Stress creates. and because of that stress rock cracks, and after cracking, breaking down you will see after continuous thermal expansion. See, rock heats up, expands day by day, rock cools and contracts by night, expands, cool, expand, cool, because of the stress you will see crack, and after that this layer by layer you will see fall, layers of rock fall off and rock becomes smaller. And in thermal expansion you will see two types, granular disintegration, individual mineral grain separate, but granite, block disintegration, rock breaks into large blocks. In hot deserts you will see block disintegration, granular disintegration. Next, exfoliation, onion peeling weathering. In this process, outer layers rock expand more compared to inner layers. Now, outer layers they expand more. After expansion, what happens? Cracks develop and these outer layers they peel off like onion peel. Here you can see the picture. Outer layers peel off in sheets results from thermal stress and pressure releases. Outer layer peel off like onion peel. That is known as exfoliation. Exfoliation, favorite topic for UPSC. Exfoliation comes under physical weathering, and in physical weathering outer layer expands more than inner layer. Because of that you will see onion peeling weathering. Next, salt weathering. In salt weathering process, saline water enters rock pores. After entering, water evaporates, salt crystals form, and after salt crystals expand and exert pressure on that rocks. Salt crystallizes. After crystallization, these salt crystals exert pressure. See, evaporation leaves salt crystals behind. Rock eventually it will break. Effective in coastal areas. They can give in maths the following: salt weathering, where you will see coastal areas like that. Now, chemical weathering. Chemical weathering, in chemical weathering you will see change in mineral chemical composition by which rocks are decomposed, dissolved or altered due to chemical reactions. Here you will see chemical reactions between minerals and agents like water, oxygen and carbon dioxide. Exogenic processes are done by geomorphic agents like running water, winds, all those things. Winds, groundwater, sea waves. It changes the chemical composition of rocks unlike physical weathering. In physical weathering you will see breaking down physically rock fragments, angular rock fragments you will see. But in chemical weathering, chemical reactions you will see. What are the essential conditions for chemical weathering? Presence of water. Presence of water is the key medium. Warm and humid climates. In warm and humid climates, presence of water is very important. Dense vegetation. When there is a dense vegetation, you will see organic acids. Permeable rocks with joints. If a rock is not permeable, chemical reaction does not happen. Permeable rocks with joints and fractures. Here, first in chemical weathering, first type of chemical weathering, hydrolysis. Hydrolysis, most powerful process. What happens here? Reaction between water and silicate minerals. Reaction between water and silicate minerals you will see. Here hydrogen ion replace metallic ions. For example, feldspar reaction, when it reacts with water, you will see clay formation plus soluble salts. In a statement they can ask, clay is formed from feldspar because of hydrolysis. Hydrolysis. Clay mineral formation. Next, hydration process. Here minerals absorb water, volume increases leads to expansion. Here minerals absorb water. Hydrolysis, hydrogen ion replace metallic minerals. Here volume increases leads to expansion and cracking. Rock disintegration and further weathering you will see in hydration process. Carbonation is very important. Carbonation, carbon dioxide plus water produces carbonic acid, H2CO3. This carbonic acid reacts with calcium carbonate. After reacting with calcium carbonate, it will produce calcium bicarbonate, which is soluble. Now calcium carbonate is hard, limestone. In limestone you will see calcium carbonate, and this calcium carbonate is converted into calcium bicarbonate and it becomes soluble. When it becomes soluble, you will see different types of landforms, stalagmites, stalactites. Because the soluble calcium is carried away by water. Because of that carried away by water, you will see, if this is a limestone rock, in this limestone rock COCO3 is converted into calcium bicarbonate, and this bicarbonate is soluble in water, and this bicarbonate is washed away by water. Mainly limestone, chalk, marble, in these three you will see carbonation processes. It produces sinkholes, caves, stalactites, stalagmites or karst landforms. In landforms we are going to discuss in detail. Oxidation process, reaction of minerals with oxygen. In oxidation processes you will see reaction of minerals with oxygen, similar to rusting of iron. It is similar to rusting of iron. Whenever a mineral is having iron in it, iron oxides react with oxygen and it will produce rust. What happens? It weakens rocks, produces reddish brown soil. From rocks only, rock fragments, and after rock fragments you will see soil formation. From parent rock only we will see soil formation, right? And because of this oxidation process you will see reddish brown soil formation. Increases rock porosity. Best seen in tropical regions, well drained areas where you will see more rainfall. Here in oxidation process, water acts as medium. That is why in dry climates you will see rusting. Oxidation process slow, oxidation process is slow, water acts as a medium, it makes oxidation process fast. Now we have seen physical weathering, chemical weathering, and one more weathering is there, it is biological weathering. Biological weathering means if a rock is there, a tree has been grown in the middle. This tree breaks the rock, right? Because of the tree. When life involves, because of that life involvement, any rock breaks, that is known as biological weathering. Biological weathering. Clear? Here, mass movements. Mass movement, we have three types. First one is weathering, mass movement, next erosion and transportation, deposition, all three together we are going to learn. Mass movement, here you do not have any geomorphic agent. Without geomorphic agent, you will see movement. For example, it is a rock. After weathering, rock fragments formed. After these rock fragments further eroded and they get transported or deposited somewhere else. But in mass movements, downward movement of rocks you will see because of the gravity. You know, gravity never sleeps. Because of that gravity, you will see mass movement of weathered rocks. After weathering, mass downward movement. Material, soil, debris under the direct influence of gravity. Here this you have to remember. Gravity. Gravity is very important without any transporting agent. Without any transporting agent like water, wind and ice. Gravity is the only driving force. Gravity is the only driving force here. Next, main causes of mass movement. Main causes you have to remember: removal of support from below to materials above through natural or artificial means. From below, if support is removed, then you will see mass movement. Increase in height of slopes. Gravity, you will see mass movement. Next, overloading through addition of materials naturally or artificial filling. Overloading, addition material, what happens? It becomes heavy. Whenever anything becomes heavy, you will see movement because of the gravity. Removal of material or load from the original slope surfaces. Next, occurrence of earthquakes, explosions or machinery. Because of the earthquakes, explosion, you will see mass movement. Next, excessive natural seepage, heavy drawdown of water from lakes, reservoirs and rivers. Indiscriminate removal of natural vegetation. When you see indiscriminate removal of natural vegetation, because of this, see vegetation, it holds the soil, right? And that upper layer of the soil, upper layer of rocks, you will see mass movement, downward movement if you do not have natural vegetation, if we remove natural vegetation. Mass movements are classified into slow and rapid movements. Some movements are slow, some movements are rapid, fast movements you will see. Actually, mass movement happens when driving force, when gravity force or pull down force is more than resisting force. Rocks have resisting force or resistance force. If a rock or a debris, rock force, resisting force is down compared to driving force. If driving force is more, pull down force, then you will see mass movement. Slow movements, creeping first. Under slow movements we will see creeping, moderately steep, soil covered slopes and does not require water. Slow movement here, in gentle slope areas you will see this tilted fence, tilted that iron poles. Have you observed ever? After prolonged observation, you will see this creep, zone of creep here. Tilted electric poles, bent trees, cracked walls. It's a silent killer. Slowly it will move, slowly, slow movement you will see. Here, curved trunk tree, tilted fence, broken retaining wall. Now, where it occurs, moderately steep. Now, solifluction, it is the gradual downslope movement. Gradual downslope movement. Solifluction means it is a gradual downflow movement, means simply it is a creep with water. Creep we have seen, gentle. Creep with water. Water saturated rock debris. Slow movement of this water saturated rock debris. It is a kind of creep in which the movement influenced by lubricated water. Here you have to, what you have to remember, creep, slow movement, but you don't need any water as a lubricant. Here water is necessary in solifluction because groundwater strata are occupied in between permanently frozen soil and rocks in permafrost. Here permanently frozen soil, the groundwater is stuck between permanently frozen soil and permafrost, and this water acts as a lubricant and slow creep, slow movement you will see. The very slow downslope movement of saturated soil or regolith or a rock. See, creep. Means you doesn't find any movement with an after observation. Over a period of time you will see creep effect. Next, in rapid mass movements, we will see earth flow, mud flow, debris avalanche, landslides. In landslides, you will see slump, debris slide and rock slides. Flow and slide, like thick liquid it will, you will see. And under slide, block movement, fast block movement, we will see. Fast block movement under slide, flow like a thick liquid. Earth flow, debris flow, mud flow, rapidly, fast movement you will see. Here causes because of heavy rainfall or a snow melt or a volcanic ash and water flow you will see. In slide you have rock slide and debris slide. We have seen landslide, right? Landslide, rapid downward movement of rock, soil, or debris. Rock slide or debris slide. Very rapid movement, When a snow falls, we will call them as avalanche. Here, whenever you take rock slide or landslide, in landslides you will see the downward movement of rapid downward movement of all rock, debris, even rock fall also. This is earth flow, here this is mud flow and this is rock slide. Rock fall means rock bounces and fall happens. Here rock slides. Here you will see slip surface from where the slide is happening. In slides you will see slip surface. In fall you do not have any slip surface. Here mass movements, materials involved rock slides. Slump, debris slide, rock slide are the forms of landslides. A slump is a form of landslide in main. How? Backward movement you will see, backward movement like this, backward movement, backward rotation of material. This is a slide, but in slump you will see backward movement and a slump like structure. Here you will see this is a slip surface. This is a slip surface. All slides are landslides, but not all landslides are not slides, because in slide you will see slip surface, but all landslides, for example rock fall also comes under landslide. Rock fall, landslide is a broader term. In rock fall you do not have any slip surface. Rock bounces and it will fall. Here surface is there, mounted. From here rock bounces and it will fall on the surface. But when you take rock slide, slide happens, sliding from a slip surface. Clear? Mass movement. Mass movement, weathering. Weathering means breaking down. There only, no movement you will see in weathering. Mass movement you will see movement because of gravity, that you have to remember. No geomorphic agent or no transporting agent. Next, erosion. Erosion is the process of wearing away or removal and transportation of weathered material by natural agents. Natural agents like running water, wind, glaciers and sea waves. Here you will see kinetic energy. Because of kinetic energy, movement happens. Kinetic energy is involved in erosion. Unlike weathering, inside to inside, mass movement, gravitation, erosion involves transportation. Erosion involves transportation. Agents of erosion, running water. Because of this running water, what you will see? Fluvial landforms. Next we are going to learn fluvial landforms. Glacier, glacial landforms. Wind, here you will see wind landforms in deserts. Sea waves, marine coastal sea, here bays, bay formation, barrier formation, sea caves. In fluvial you will see meanders, that valleys. In glacier you will see eskers, moraines, all errate, cirque, all those things you will see. In wind landforms you will see yardungs and mushroom rocks, different types of landforms. And one more, because of groundwater, karst landforms, limestone, karst landforms, limestone, because of mainly limestone or dolomite minerals you will see. Now we have seen rock. After rock structure, next we have seen geomorphic processes. Because of this geomorphic processes you will see soil formation. Soil formation over a time, here bedrock, immature soil, rock debris, grasses. What happens? After weathering and erosion and after organic involvement, biological processes, you will see breakdown of that rocks and that rocks into immature soil, and again because of grasses and shrubs, roots, they break down the rocks, and organic debris you will see humus formation, moles, nodules, and thin soil formation. Here you will see from rock fragments because of the organic debris, grasses and small shrubs. You will see here soil. Parent rock determines the color, texture, chemical properties, mineral and content permeability. But when you take parent rock, ditto similar soil formation you does not see, differ. Even parent rock differs, soil differs. Soil will have another composition and parent rock will have some other composition. Relief, altitude, slope determines accumulation of soil. If slope is steep, soil is eroded. Now flora fauna affect the rate of humus formation, affect the rate of humus formation. Climate, temperature, rainfall also influence the type of soil. For example, in equatorial regions, you will see thick vegetation, but soil is not fertile. Why? Because incomplete decomposition of organic matter. You will see fast decomposition, and this fast decomposed material, they are washed away because of rainfall, heavy rainfall. In equatorial regions you will see heavy rainfall. Because of this heavy rainfall, this organic matter, this decomposed organic matter is washed away. Humus creation is not complete, and even if decomposed material is formed, that decomposed material is washed away. Leaching happens. Because of this leaching, you will see laterite soils rich in iron oxides, red color. Humus does not get time to stabilize. Here fast decomposition, so humus accumulation does not happen because they are washed away because of heavy rainfall. Laterite soils they are poor in humus but very rich in iron. Based on that, in one of the prelim question was framed based on that equatorial region question. Now, peat is an organic soil formed due to incomplete decomposition. In equatorial region you will see fast decomposition, but peat incomplete decomposition of vegetation under waterlogged condition. If water is logged, anaerobic environment, you will see peat formation mainly in tundra and temperate wetlands. Dense vegetation grow, grasses, mosses, all those things grow, dead plant material accumulates. After that waterlogging, because of that waterlogging you will see lack of oxygen. Because of the lack of oxygen, microbial activity slows down. So, incomplete decomposition happens. Because of that incomplete decomposition, you will see peat formation. Organic matter partially decomposes. Thick peat develops. Here, dark brown to black. Characteristics of peat: dark brown to black, spongy texture, very high organic matter, acidic, but nutrient content is low. Peat is not equal to humus. Humus is different. Peat is different. Humus, here decomposition in peat is partial, humus complete. Oxygen condition anaerobic, in humus aerobic. Here stability less stable. Peat is less stable. Humus is highly stable. Fertile, peat is low fertile, humus is high. Horizon, O horizon, it is in A horizon, upper layer. Here, O upper layer, top soil E, elevated horizon B subsoil, C parent soil, R bedrock. So, tomorrow we are going to discuss landforms along with MCQs. This is a rapid revision class, that is why we are going very fast. Revise rapidly, very useful for your UPSC 2026. Tomorrow we are going to cover landforms. Quick revision along with MCQs. Thank you.